Hello everyone, you're welcome to class again. And today we'll be dealing with optical instruments part 2, where I will be talking about the eye and then maybe a little couple of some other things, and then we'll call it a day. Make sure you listen attentively and pay rapt attention because it's important both for your general physics knowledge of your examination. I'll go ahead and share my screen now so we can get straight into the business. Yeah, optical instruments part 2. And now we'll go straight into talking about the human eye. The human eye is the biological organ. It's a biological organ for sight, which is composed of cornea, aqueous humor, vitreous humor, the iris, retina, the lens, among other important components. Now, in order for me not to be abstract, let me quickly talk about the important components of the eye. Important components of the human eye. Number one, I'll make mention of the cornea. A very brief explanation of that, it is the transparent or front layer that refracts or bends incoming light. Keep that in mind. Very important for multiple choice question. I'll go straight into the aqueous humor. Now call that the clear fluid between the cornea and lens that maintains pressure and nourishes the cornea and lens. I'll go straight into the pupil. This is the central opening in the iris that controls how much light enters the eye. Go straight into the iris. This is the colored part of the eye that adjusts pupil size to regulate light entry. Take note of that. I go straight into the lens. And the lens is the transparent, flexible structure that focuses light on the retina by changing shape. And that concept is called accommodation. So I can quickly define accommodation is the focus of light on the retina by changing shape using a lens. Keep that in mind. Number 6, I'm going to talk about the ciliary muscles. Controls curvature of the lens for focusing near or distant objects. Keep that in mind. The next thing I'm talking about is vitreous humor. Vitreous spelled V-I-T-R-E-O-U-S. Humor. Clear, it is the clear gel-like substance. Filling the space behind the lens that maintains, so this fluid maintains the eye shape. The clear gel-like substance filling the space behind the lens, you can say that maintains the eye shape, or you can replace that with and it maintains the eye shape. Number 8, talking about the retina. The retina is the light-sensitive layer at the back of the eye. At the back of the eye that converts light into electrical signals. Keep that in mind. Rods and cones. Photoreceptors. They are photoreceptor cells where the rod plays the role of detecting dim light. Black and white. Why the cone detects color. You are getting the point. So we are moving and reading and moving and improving. We talk about another part called the macula. Macula, M-A-C-U-L-A. Macula and fovea. This is the central region of the retina. Responsible, which is responsible. So this part is responsible for sharp, diluted vision. 11, optic nerve. This carries visual information from the retina to the brain. Then, in some places they call this sclera, some call it sclerotic. So this is the soft, white outer coat, can be called sclerotic coat, that protects and gives shape to the eyeball. Keep that in mind. There is another part called the choroid. C-H-O-R-O-I-D. It is the layer containing blood vessels that supplies oxygen and nutrients to the retina. So now we have listed the important parts of the eye, and I'll be bouncing straight into the similarities between the human eye and camera. Similarities between the human eye and camera. Number one similarity is that they both have light sensitive screen. Take note of that. Number two, this is a very common exam question. They both form inverted images. Yeah, that reminds me. Let me see if I can review the definition of the eye. Okay, let me see. Okay, I say, okay, let me go back to the definition. The eye is biological organ for sight, which is composed of cornea, among other important components. And forms, just had a line there, had a line, and forms real and inverted image of external object on the retina. So that's just to make the definition of, definition of the eye more comprehensive. And let me move these things here, put them down a bit, okay. So look at it. So I give you like 1 minute to add that line. So among other components, we said the human eye is the biological organ for sight, which is composed of cornea, aqueous humor, vitreous humor, iris, retina, lens, among other components, and forms. So that's the role of the human eye. It forms real and inverted images of external objects on the retina. Yes. So 1 minute I give to you to write. And then I shall now proceed. Both form inverted images. The third one is that the amount of light entering both can be adjusted. That's the role of the iris, or what we call the diaphragm. Take note of that. Both have light-proof interior. Take note of that. Light-proof interiors. Both have light openings. So, and in bracket, pupil stroke aperture. So take note of that. In the case of the eye, it is the pupil. In the case of the camera, it is the aperture. Those two things play similar roles, and that's light opening. Let's go straight into the next subtopic. And that is what I will call the differences between the human eye, and the camera. My number one difference, or let me put it in, I love to put them in tabular form because, you know, get what I mean? Examination style. So let's say number one, distance between the lens and retina is fixed for the human eye. But in the case of the camera, the distance between the lens and retina is adjustable. That is, it can be changed. It's adjustable. Number two, the lens of the human eye has variable focal length, while the lens of cameras are fixed. Keep this in mind. Number three, it is a biological organ. That's for the eye. While this is a mechanical device. This, for the eye, it exhibits persistent and binocular visions. The camera does not exhibit persistent and binocular visions. That's where we stop on the differences. Now we bounce into the next subtopic, which is eye defects. Very interesting one. One of the reasons why it's interesting is because I have 4 eyes. Eye defect. Number one, presbyopia. Presbyopia. This is the loss of power of accommodation due to the hardening, please pay attention, or weakening of eye lens, or the loss of elasticity in the ciliary muscles due to old age. Take note of that. It leads to the inability to focus near objects. And I will call something the correction for presbyopia. Correction for presbyopia. It can be corrected by using converging lenses. Just to make sure you're active in class, I will give you 1 minute to go and tell me another name for converging lenses. Put it right here. Or another name for converging lenses. I give you 1 minute. Everyone, 1 minute. go to your previous part of your notes. It can be corrected by using converging lenses or another name for converging lenses. Go and find out 1 minute. When 1 minute is over, I will write the answer and we'll proceed. So your time is counting down. Converging lenses? Yes. You that said the answer is that, you are right. You that said maybe, okay, don't worry, in some seconds, I'll give you the right answer. Converging lenses. All right, correct. Convex lenses. So let's continue. The other defect we shall consider. Number 2, myopia. Short sightedness. This is the ability to see near objects clearly, an inability to see distant objects clearly. And it is due to long eyeball or strong eye lens of short focal length. So what happens in myopia? In myopia, the image of distant objects is focused in front of the retina instead of on the retina. So the correction of myopia it can be corrected by diverging lenses. Give you 2 seconds to tell me another name for diverging lenses. We have already talked about converging lenses. You are right. Concave lenses. Or concave lenses. Now, I want to quickly take a pause. You catch a breath. I want to see if I can give you a sketch of what happens in the case of myopia. In the case of myopia, I'm going to see if I can give you a sketch of what happens. So, and I mean, when we use a converging lens, sorry, a divergent lens rather. So let's say this is the eye. I want to give you a sketch. This is the, let's say this is the eye. You know, and you put and this is the eye lens. Let's say this is the eye lens, normal eye lens in front of us here. And then we put a concave lens or a diverging lens here. When light is coming to travel, and then travel through the lens, normally go through the eye. And the eye normally brings it to focus on the retina, but when there is problem, it doesn't touch the retina. Problem. But now when we bring the role of this particular diverging lens now is that to bring light rays from the person's far point. Let me redraw that. To bring light rays from the person's far point and make it to diverge and fall on the retina. So, correction. Now falls on retina. So the problem falls before, in front, falls before the retina. So that's just the idea. I'm just using this to paint the idea to you. So the original light is traveling and falls before the retina, but when you allow that light to come, through this is the diverging lens, it now falls on the retina, right here, the appropriate place. So please just take note of that idea, and let's run back to talking about defects. Defect number 3. And defect number 3 is what I will call hypermetropia. And that is otherwise called long-sightedness. And this has to do with the ability to see far or distant objects clearly, and the inability to see near objects clearly. So the ability to see far and not be able to see near is long-sightedness. And it is due to short eyeball or weak eye lens of long length. In hypermetropia, the image of near objects are focused behind the retina. So the idea here is now, let me before we talk about the correction, before I give a rough sketch. Correction of hypermetropia is corrected with converging lenses. And the idea here is, we have the eye, the big eye. Then, okay, let's say light is traveling, And normally for this defective eye, it bounces somewhere here, the problem. So when you put a converging lens, now comes and to now make it to converge. To make it to converge here now. Are you with me? On the retina. This is problem. On the retina. This is correction. This is a converging lens. So that's the idea. So originally, the problem makes it to fall behind the retina. This is where the retina should be, but it falls beyond it. So, but you see the correction makes it to fall in the right, the appropriate place. So keep that in mind. So, and a good way to draw it is, let me just make a little adjustment. These traces, at this point, they have to go through the top. Understand? So I mean, we already have this. Then we have our normal. Okay, let me have our normal lens here. We have the eye. So these traces have to go through like this thing. Go through for the now. Bend. So causes it to exactly. So keep that in mind. Oh, it's just okay. Just make sure you just draw it well. I think the previous one was fine. Let me just take it back. Sorry if that confuses you. You should be using a pencil to draw. Anyway, if you use your biro, just get the point that, yeah. It's a very simple idea. When you just pass it through, you understand? This converging lens, it kind of converges to this. So I think this one is much better. So let's just move ahead. Nothing should be stopping you. If you make a mistake, clean it, or just cancel the entire diagram very neatly, a single stroke, redraw. We are moving. Nothing discourages you, nothing depresses you. We move and you study hard. Let's go on. The next thing, we just talked about number 3, hypermetropia. Moving on to the next one, that is astigmatism. Number 4, astigmatism. That is the ability to see objects more clearly in one direction than the other. Can only see in one direction than the other, or you can say it is the inability to see objects clearly in different directions. So please take note of that. The blurring of vision is the convergence of light rays into two focal lines, right angle, rather than a single focus. So it's split into two focal lines instead of one single focus. And it is due to uneven curvature of the eye lens or the cornea. or both of them. In youth, astigmatism, or you say it has a greater curvature in the vertical meridian and with age it becomes greater. Let me write this is it. It becomes greater in the horizontal. So when for somebody with astigmatism, when he was young, there was a greater curvature in vertical meridian. Then as the person is going old, that thing becomes greater in the horizontal. So for that person, a perfect, so it is such that a perfect horizontal line cannot be drawn by such individual. Horizontal line cannot be drawn with a free hand. By such individual. So just keep that one in mind. Before we call it a day for today's class, I'm just going to give a summary of images formed by different optical instruments. Summary. Let me see if there's something left before I give the summary. Okay. Take a minute to catch your breath. If I see if there's anything left, if I give the summary. So I've talked about a couple of optical instruments. It's time to just give a summary of the kind of images formed by them. Summary of images formed by optical instrument. There are some of them with, we say they have single lenses. Single lenses. And those are things like projector. Projector forms RMI. You should know the meaning of that by now. Real inverted magnified. So don't worry, I'll give you the code at the end. Camera or eye forms RID. That's real inverted diminished. Then simple microscope forms VEM. Virtual erect, and that's magnified. Virtual erect magnified. Then there are others called double lenses. And the one with the double lenses, compound microscope. They form two kinds of, since they have double lenses, they form real inverted magnified or virtual inverted magnified. Another one, astronomical telescopes. Talked about this. Astronomical telescopes. Astronomical. Let me make sure I'm spelling that right. Astronomical. It forms also RID stroke VIM. That's real inverted diminished or virtual inverted magnified. Then others, whichever one you want to think of, real inverted diminished or virtual erect magnified. So the idea here is that R stands for real, I stands for inverted, M stands for magnified. Magnified means increased or enlarged in size. Then V stands for virtual. D stands for diminished, reduced size. E stands for erect. So I think basically that's all that we use in the key. So take note of the fact that for some of these instruments with double lenses, whenever it forms virtual, it has to be for compound microscope, for example, the virtual is magnified. It's quite different for cases of astronomical telescope because its own virtual is magnified too, yeah. But its own real is not magnified, it's diminished. So please just take note of this, study it, put it in your head, but beside your normal reading of all those things. So in case, object questions come out like that. So this is why you don't have time for rubbish play. Study hard, and I will see you in my following classes. Thank you.